Hey, and welcome back. In this video, we're going to be looking at while loops. So last couple of videos, we looked at covering for loops and the nesting of lists. But we're moving away from understanding or knowing the exact size of our lists and moving on to how to keep running code until we meet certain criteria. Okay. So while loops is a iteration where you use when you don't know how big your data size is. So on contrary, the for loop iterates over a known sequence. So that is, if you know exactly how many items there are, we can use the for loop quite easily to go through each item and do something. But sometimes we do not know or have understanding of the structure of the sequence that we are given. For example, stir until boiling, and we don't exactly know how long it's going to take for something to boil. Keep reading input until the user types quit. That's another type where we don't expect users to have specific number of interactions with the program, and keep refining the answer until it is good enough, for instance. So there are certain situations where we might have to deal with uncertainties, and in those cases using the for loop is not feasible because we have to understand what we're iterating through. So instead what we can do is use the while loop, and while loop structure is actually quite straightforward. The syntax is while condition, you give the statement. So while this condition is true, it's going to keep executing its while loop block, and therefore you have to be careful with the while loop that you are modifying or checking that the condition or condition variables you have is being updated within the block. Otherwise, you get into a condition. You get into a state where we call an infinite loop, where you're stuck inside, and eventually your program will crash by running out of memory. Okay, so let's have a look at some examples. So the first example is bacteria, where we want to calculate how large the size is or how long it takes for the bacteria to reach a certain population size. So we have to understand some characteristics of bacteria population. So here, for example, we assume that bacteria increases in size by 21% every minute. Then how long does it take for the population size to double? Okay. So we can start with 0 as our initial condition, and then we also have some initial population, but here the problem is to calculate when it doubles, so it doesn't really have to be this specific value 1000, but you can use anything else. But that's a good number to start with, because we are multiplying it by 0.21. If we having decimal points, then the calculation may not be very accurate. Nevertheless, this is our setup. Then here's the while loop. While population is less than 2000, then we're going to do something. And essentially what we're going to do is we need to do two things: increase the size of the bacterial population and increase the minutes that it took it to do so, right? So population becomes times equals 1 plus the growth rate. So essentially what it's doing is population equals population times 1.21. Okay, so after the first round, it should have reached, yes, 1,210, right? So after 1 minute, it's 1,210, and this is going to repeat because when we come back to the population, 1,210 is still less than 2,000. So 2,000 is our target. We want to know how many minutes it takes to go over that number. Okay, and then we can print it out. So let's have a look using the code. Okay, so this is our code that we have. Okay, I run it. Okay, and population reaches 2,143, and it says 4 minutes required. Okay, So we can see that if the increase rate is 21%, it only needs 4 minutes to reach the size of double. And you can easily change this rate. So for example, 0.5%. So if the growth rate is 5% and we run this, then it's going to say, oh, it requires now 15 minutes to double its size, and it's going to reach 2078. Okay, so this number of minutes actually represents how many times the while loop has been executed. Okay, so for now, for example, change the growth rate to 1, then it should only run once, right? Because after 1, it basically doubled, so now I can stop. Okay, and any value greater than 1 should also stop after 1 minute. So this time, it only ran it one time. Okay, so how does it look like in terms of the flow diagram? Well, we have initialized all the variables up here, and we check the condition first. And if the condition is not met, we're going to continue doing the while loop block and always come back to check whether this has been achieved. Okay, and if this condition is satisfied, then we can move on to the next part of the code. So in this instance, we can print out the results. Of course, you can have some other stuff in there. Okay, so as mentioned before, while loop is where you can easily get into an infinite loop. Infinite loop is also possible in the for loop, but that is really rare. While loops are more often the cause of infinite loops because the condition never gets updated inside the while loop block, and therefore it's never achieved. So you have to make sure that the condition you set inside the while loop eventually becomes true, otherwise you're stuck in there. Hence called an infinite loop. Okay, so this is a very common bug, and probably if you do more coding, eventually you will hit 1 or 2 infinite loops when you make some other programs, right? So for example, in the previous program, if we did write something like while population doesn't equal 2000, then this will likely to get us into an infinite loop. Why? Well, if you looked at our output before, 0.21, and run it again, the population reaches 2,143, and before that, it's probably something like 1,000 something, right? So in that sense, the population value will actually not end up being 2,000 to terminate. It's not a counting value, it's a computed, so it skips big numbers at a time. And therefore, we will never actually see population being equal to 2,000 in many of the scenarios. Therefore, population now will be greater, but since it's still not equal to 2,000, the while loop never ends. Okay, so I have to be very careful with it. If you do get yourself stuck in there, you can use options restart shell to restart it. So here, options and restart shell there. We have seen it before. This will clear out all the namespaces as well. So you have to run your code again. But before you run it, to fix your infinite loop as well. Okay. So recommendation is always test with debug if you're unsure whether you're going to be stuck in the infinite loop or not run. Okay. So then we can always just press stop of the debug to easily kill the program that may be stuck in an infinite loop. Okay, and again, a reminder to not compare floats for inequalities. Let's have a look. So the debugger in Wing 101 is actually quite useful. Sometimes you need more than just running a program. So for example, when the program does not terminate, the infinite loop, as we've seen before, when the program does not produce the expected output. Okay, so you were thinking it's going to generate result A, but your program returned result B, then you wonder why. So we need to know what's actually happening to the values that we have assigned. Okay, so instead of running the program, we can debug the program to follow up how those variable values are updating, and are those updating as we expect. Okay, so let's do the debugging with our Wing. Okay, There are a few other things you could do in the debug, like setting the breakpoint, so you don't have to actually stop at every single line of code. You can skip to the breakpoints you set. But of course, you can look at each step and see how those values gets updated line by line. Okay. So let's change this to doesn't equal 2000, and let's just run it to see what happens. Run it. Okay. So here you see it beeps twice, but until I get the three inequality signs together, it means the program is still running. So you can easily check by trying to type something, but it doesn't show. So that means it's still stuck there. It's still trying to calculate something, but it's not going to, right? And we don't have an option to terminate, and therefore we have to restart our shell. Okay, and sometimes this not be an ideal thing. So all I can do is use a debug, right? So I think this while loop is the point of failure. So I'm going to put a breakpoint. So what you have to do is just click the left mouse button next to the line number, and this is going to show us a big red circle. And you can put breakpoints in multiple lines if necessary. Okay, but I just want to put inside the while loop. And here, debugging, you have to press this bug button. Okay, so this will get us start to debug. So let's do that. Okay, so let's debug this. So you press this bug button, and what's going to do is it's going to run the code until it hits the breakpoint that I set. So it's now stuck here. We need some bit more look. Okay, and the place you want to look at is the exceptions and the call stack. So you want to have a look at both of them. And you can have a look at the stack data, and inside stack data, this is where all your variables are stored. Okay, so let's find our variables. Here we have the growth rate defined as 0.21. This is globals because we haven't put this into a function. We also have minutes at 0, population at 1000. All right, so we have these three variables assigned up here. Okay. And then what we're going to do is press F6. This is go to the next line, so F6. So now what we did is we entered inside the while loop. Okay. And then now we're looking at the line population times equals 1 plus the growth rate. We still haven't got an error yet, so that's all good. Okay. And then we go over. So by this, after executing this line, you can see that the variable has updated to 1210, and then we move on to the next. So we go back, so you can see that the minute has updated from 0 to 1, and then we are back into the while loop to check whether this condition is met. So you can hover your mouse over to the variable, and it will also tell you that this variable has value 1210 at the moment. Okay, so let's continue this. Okay, I went through another cycle. So if I hover my mouse over, it's now 1464. So this is after 2 minutes. I can continue doing this. If you are going over a line where it's calling a function, then you will instead use F7, or this step into button. Then it will take you into the function to see what the function is doing. Okay. Or if you want to escape the function that you're in, you can just press F8 to pass that. So here now we have reached population 1771. It's all right, so we're still good. Our next cycle, so we can see that the population has reached over 2000, but 2143 isn't equivalent to 2000. And therefore, if I press F6 again, which is to see the next line, I'm going to go into the while loop again. Okay, so at this point it's now 2,500, 3,000. Okay, and this is keep increasing. So what it means is my population is keep increasing and the minutes are keep increasing, but I will never get out of this while loop because my population will never reach exactly 2,000. Okay, so I know that now I'm stuck, so I can get rid of this by pressing the terminate button. Okay, so here I'm in the debug IO. If I print anything, I will show. Okay, so I'm not using really shell to debug. So this gives us a better closure. What's happening? Oh, my population was over 2,000, but it was never caught. Therefore, I must change this equality sign. So let's change this back. While population is less than 2,000. So now let's try this debugging again. Press this debug. I go here. I scroll down to the globals because my variables are global variables. I can see them. I can go over and then I can see them update as I go each step. Okay, and at this point I reached 2,000. I go back to the while loop to check population is less than 2,000, and because this time this condition has been satisfied, I'm not going to go into the while loop. I will move out into the print, which is at line 315. So if you press F6 again here, I should skip everything and move on like this. Okay, then I can print. So our debug input output shows that we have printed this out, and then finish this. Okay, and then there's no more code to execute. So after pressing the F6 again, my code stack finishes. There's nothing else to do. Okay, and you can see that the debug also finishes as well. All right, so hopefully that debugger is quite helpful to you. So if you're interested, how it works is in a memory space, if you have a bunch of instructions, then the computers are going to store them into a stack. And basically, instructions put it into the stack one at a time, and the latest instruction gets executed first. And if that instruction calls another function or another instruction, then the new one gets keep on putting on to the top. So by doing that, you can eventually come back to where you left off. So if you are interested in learning more about the stacks, actually you should really go into about data structures and algorithms. So I will not go over too much details about stacks in this video. Okay, so you can read this, but I will not be examining you regarding the stack in this particular unit. Okay. Anyway, so going back to the while loop, let's have a look at another example. So we had a look at spread of bacteria, but another example is if you are interacting with the user. So for example, user may be interacting with the program to keep inputting some tasks, and maybe eventually the user will quit if they do something else, or if they press some specific key, right? So consuming some input data sequence until some condition occurs, for example, loop processing commands until user enters quit. So that's a typical example that we've been describing. Loop until user gives a valid response as well. So this is to check whether the expected input is what we were expecting or not, or search through a sequence for the first occurrence of something. Okay, so all of these are valid usage for dealing with input loops. Okay, this is a little bit tricky because it doesn't quite immediately translate into a while loop. We'll have a look. So a flowchart view of this is that we can read a line, and then are we finished? We checked inside as a while loop, and then we can process it if it's not finished, and we can try to read again and finish. So flowchart wise, it's quite straightforward, but how do we solve this, right? Because in the while loop, this is the returning point of the program, and therefore, if we write a while loop inside the program, the backpropagation arrow should be coming back here instead of there. So how do we make sure, how do we get this arrow to come back here? That is probably the problem. So there's a few different ways of doing this. Let's have a look. So the three common solutions are, first, 1.5 loop, which is you get the item and then you do the while loop and you get the item at the end of the while loop. So when you come back, it has the same property that you got the next item already at the end and then process it again. Okay, that's one way. Use of a Boolean flag is another possible way. So is done, you create the is done flag, and while not is done, we get the item and we process it, and at the end we check whether we have finished or not, and if we did finish, we can convert our flag to true. Okay, and either of those are fine solutions, and the choice depends on situation and personal preference, but either way, they're both really good solutions. And the third one is using break. However, using breaks are not really recommended because often it is quite difficult to understand exactly what condition is needed for the while loop to be breaking out of. Okay, but essentially when you call a break, it's going to break out of the loop that you are currently in. Okay, so if you're in a while loop, it will break out of the while loop. And you can use the break inside the for loop as well, but again, those are not a recommended action. Okay. So looping until quit. Okay. So our first one was we read it and then do something with it and then read it again at the end. So that's our first example. Our second example using the flag is we create a Boolean variable and then we take the input and then we calculate whether we quit or not. Okay? So all of those are some example of how we can implement looping until when user enters the quit command. So now we can convert them more into Python specific code. So here it is still Python specific, but we skipped a lot of code. But here you can actually try these yourself. Okay, so let's get rid of the debug stuff. Comment this up. Uncomment this. So this is our idiom 1. Run it. Okay, what suit? Okay, so I can keep typing something, but this code is going to say invalid suit, try again, which means it's going to keep asking me until I find, enter the suit that is the same. So here I can say apple, right? It's invalid, try again. It tells me the options. Okay, I can say tree, it's still invalid, some random characters. Okay, and eventually I'll get to character clubs, then it's going to execute, right? So no matter how many attempts I have, when I provide a valid input, then it will terminate. This is the true for our second example as well. Okay, so we run the same thing. I have some tab problems. Okay, so I run this code again. It behaves exactly the same as before, so I can just keep typing some random stuff and it's gonna keep asking me until I type in something that exists. And actually the code does deal with uppercases, so I can type in all uppercases, doesn't matter because it's finding the lowercase of that. Okay. So we had a look at about break statements, and the recommendation is not to use it, but it's a good idea to understand what it does. So break forces an immediate exit from the loop. Basically, it goes straight to the first statement after the loop. So basically, you're skipping all of the block of the loop that you had and go through, skip through until the next line of code, right? So this is actually quite easy to use if you think about it, but a loop termination condition is no longer explicit. That means if you had a while loop condition, but you have some break somewhere inside, now you have multiple conditions to finish the loop, right? So this makes it more difficult to trace exactly what your program is doing. Again, we're going back to that concept of maintainability, things like that, and this is not a good idea, okay? And it also kind of encourages a lazy style of programming and yeah, maintenance problems. Okay. So break statements in Python can be used something like this as well, but obviously we're not going to emphasize on using it because of its limitations. Another one you should know is continue. So continue is actually often used to just say that continue from this particular expression. So where break terminates the loop, continue will only skip the current iteration and it will move on to the next iteration if you do encounter some errors with the current one. So continue on, we'll go back to our expression and run it again, whereas the break will break out of the loop straight away into the exiting of the loop. Okay, so the use of the continue statement kind of looks like this. Continue statement in Python returns a control to the start of the current loop. Okay, so let's give this a go. Okay. So what do you think this particular code will execute? Well, print. Let's find out. Let's find out. So here it gives me 2 and 4, right? So what it did was it did I modulo 2 equals 1. If that's true, then it continue. That means if my number is odd, then I will go back to the next, I will go back to the top of the loop and move on to the next item. So here, when I came across 1, it did 1 modulo 2, which is 1. It meant continue. So I'm skipping the print and go back and move on to item 2. And this condition is false, so I will print 2, 3, skip, 4, I print, 5, skip. So that's why I only have values 2 and 4 printed out of this loop. Okay. So the difference between the break and continue will look like this. If I'm breaking out in the middle, I'm skipping all of the block of the iteration that I have. But if I am doing the continue inside, then I'm going back to the beginning and moving on to the next data. All right, so that's it for this video. We looked at conditional loops using while, and also how we can use while for different scenarios, as well as looking a comparison of break and continue. All right, hopefully you found something useful, and I see you in the next video. Bye.